All right, properties of functions. So what we're going to be dealing with in this section is learning some tests for various types of functions. One of those tests that we'll start off with, first one, is the odd, even, and neither test. Okay. So functions can be odd, they can be even, they can be neither, just like numbers can be, but functions can be that as well. It's the great thing about that is it's only one test that you have to do, and that would be that you plug in negative x to the function and simplify. So really you're find f of negative x. That's what you're doing. Okay. That's what the odd, even, and neither test. We actually did this when we were talking about function value, or we did problems similar to that where you're just plugging in. You're not going to get a number back. You're going to get another equation back. Okay. And so depending on how that equation comes back to you, whether the function is odd, even, or neither. So if f of negative x comes back to the original, so f of negative x, when I plug that in and simplify it, it comes back to be f of x, the original function. If it turns back into the original, like everything worked out to be the same as it was, then f of x is even. Okay. So if everything comes back to the way it was, it's even. Okay. The way I kind of think about that, I think about my dad. He's pretty even keel. No matter what negative happens to him, he comes back about the same as he always has been. Okay, just real even. Okay, so when you throw that negative x in there, you come back to be the same way you were to begin with. You're even. Okay, that's what that does. If f of negative x turns into negative f of x, then f of x is odd. So what does that mean? Negative f of x means everybody is the opposite. Everything changes signs. We're going to do some examples here in a second, but everybody changes signs on the opposite. Okay, so if it was positive 3x squared and you plug in that, or that wouldn't happen, but if you plug in it's positive 3x cubed, you plug in a negative x, that's going to turn into negative 3x cubed. So it changes the sign of everything in the problem. Everything has to change for that to happen. If it doesn't, if f of negative x does not equal f of x, or f of negative x does not equal negative f of x, then f of x is neither odd nor even. Okay. So if it doesn't fit one of these cases, it's neither. In the grand scheme of functions in the entire world, most of them are neither. In this particular section, they kind of concentrate it to where you see several that are odd, several that are even, and a few that are neither. But in the grand scheme of things, most functions that you deal with are neither. But in this section, you'll see, hey, they're kind of loading the deck here and saying, yeah, we need you to see a bunch that are even. We need you to see a bunch that are odd. We need you to see some that are neither. But in the grand scheme of things, most of them are neither in the big world of math. Okay, so let's look at a couple examples of that. So is the function odd, even, or neither? All right. So first function, f of x equals negative 3x to the fourth plus 6x squared. Okay. So if we're testing for odd, even, or neither, then we're going to plug in negative x to the problem. So So that's going to be negative 3, negative x to the fourth power, plus 6, negative x to the second power. We're plugging in negative x, and then we're simplifying. So order of operations takes the lead here. So exponents first. Negative x raised to the fourth power. That's negative x times negative x times negative x times another negative x. There's 4 of them. Negative times negative times negative times negative turns into positive x to the fourth. Positive x to the fourth times negative 3. Yeah. So that piece right now, it's the same as the original. Okay. When I square negative x, what does that turn into? Positive x squared. Positive x squared times 6 comes back as positive 6x squared. Is that the original? Yes. So what do we know about the original function? Even. Now, here's a shortcut. Look at the original function. Look at the exponents on the variables. What do we notice about them? They're even exponents, right? Then it's all, if all the exponents in the problem are even, or all the exponents on the variables are even,